A very, very good afternoon to you, and welcome to Tele.net's webinar, which is driving future-ready connectivity in for data centers. This is a webinar being organized by Tele.net and being supported by Belden. My name is Alok Brara. I'm the publisher of Tele.net magazine, and I'll be moderating today's webinar. Surging data volumes and multiple network applications require data center infrastructure to be dense, to be flexible, and to be scalable. Structured cabling solutions can help in meeting these requirements as it supports very high data rates, offers greater bandwidth, and allows error-free transmission over longer distances while being immune to noise. As a result, structured cable solutions are emerging as a key component of data center architecture, helping enterprises, hyperscalers, cloud solution providers, and multi-tenant data center operators to build future-ready infrastructure. The mission of this webinar is to discuss the importance of fiber cabling in the data center domain, its key advantages, and the best practices in deployment. So today, we are going to have a presentation to begin with by Belden. And after that, we are going to have a panel discussion where we will hear from SIFI, in terms of from Girish Dawale, CTO, SIFI Technologies. We'll hear from Amit Kumar of Amazon Web Services. We will hear from Anil Nama, CIO of CtrlS. And we, of course, will begin with a presentation by Mahesh Mahamunkar, who is Business Director at Data Centers for APAC at Belden. Let me briefly introduce Mr. Mahamunkar. Mr. Mahamunkar is a seasoned professional with over 21 years of expertise in data center design and solutions. He's currently serving as the Business Development Director, APAC, at Belden, and he plays a pivotal role in driving innovation and excellence in the dynamic field of data centers. His role as the data center specialist for APAC region involves collaborating closely with high-touch accounts, partners, and internal teams to deliver cutting-edge and tailored solutions that align with the evolving needs of the data center market. He leverages his technical expertise and leadership skills to mentor and train other professionals in the field, emphasizing the importance of continuous learning and skill development. So welcome all of you, and very warm welcome to you, Mr. Mahamunkar as well. Mr. Mahamunkar, we're ready for a presentation by you, sir. And welcome Mr. Nama and Mr. Kumar. I'll be introducing you soon after the presentation, sir. Thank you. Yeah. Mr. Mahamunkar,
thank you.
You can start presenting, sir.
Sure. Let me share my screen.
Yeah. We have to give him the rights.
So you can press share screen. Is it working?
Yeah, sure. I hope the screen is visible to everyone.
Yes, it is.
Okay.
Yes, it is.
So thank you, Mr. Alok, for the lovely introduction. And I would like to thank each and everyone who joined in this particular webinar. And I will basically make this webinar a little shorter so that we can spend more time on the group discussion and the technical discussion. Okay, so let me begin with my first slide. As everyone know, we have all the data centers from various verticals, be it hotel industry, be it government buildings, be it e-commerce industry, banking, finance. Everybody has got their own central processing unit, or basically they have their business critical applications. So all these years, you would have seen the commercial buildings, hosting enterprise kind of data centers. Okay, but nowadays, you will see the new trends coming in, wherein some non-business critical applications are being hosted on something called colo data centers, and there are few applications which are latency sensitive applications that can be hosted on the edge data center. So you will see the same commercial premise getting shipped into a full-fledged data center, and then servicing various business critical applications. Okay, so But then I just want to give you some background about what is happening in this particular market. What are the changes happening in this particular market, especially in India? So I'll just give you some data which I got it from some agencies which are basically into counting number of internet users, and this data has been fetched a year back, because for 2023 we'll get this month. So as for this data, nearly 720 million, that is 50% of the population of India is using internet. Okay, now you'll be surprised to see the rural India is having more penetration of internet than the urban India. Okay, now you may say, like, why so? Because if you look at maybe 10 years back, a decade ago, internet was accessed on the laptop and desktop, right? But, or maybe 15 years back. But nowadays, people have smartphones. All the transactions, we do it on the smartphones. Just to give you some example, when you go to the local market, if you want to purchase anything, we normally use UPI apps from our smartphones, right? And this smartphone penetration until, I would say, 2022 was 66%, and it is going to cross nearly 70% this year, this particular financial year. So you can imagine the use of the various applications for your day-to-day purchases or for the business applications are more dependent on the smartphones and a bit on the other mobile devices. Now, from where these people access all these applications, there has to be some data center, whether it is on-premise or hosted or colo, right? And but then there is a catch. If my data is not secure, then is there any regulatory body, like we have RBI for banking segment, we have SEBI for stock exchange? Do we have any regulations? And that is where this particular discussion started. The most of the people would have heard that there was a news in that probably a couple of weeks back or a month back, where some of the data was taken away from the Apple application or Apple phone users. Now that is the big concern for most of the customers, whether they are from urban or from the villages. And for that, the government of India has done a fantastic job by introducing DPDP bill this year. Okay, so this bill is passed, so that basically protects the data of each and every user, whether you're using the data through your mobile phone or from the laptop or desktop or whichever way you want. So you have been protected, and there are heavy penalties if that particular data is breached. Okay, so now it's a collective responsibility of the data center service provider, the enterprise data centers, maybe it is some corporate data center. So everyone has got a responsibility to kind of protect all your data. Now, that basically encourage the service providers or data center hosting service providers to set up their data centers in India, right? So therefore, you will see a lot of investment happening in India on the data center. With the localization, that you have to have a robust connectivity. India is a large country, and there are many multiple metro cities. Now, how you connect those cities? Of course, with a fiber cable and some other connectivity technologies, right? I just wanted to basically highlight, something to you. In this particular bill, the penalty for personal data breach, which is ranging from 50 crore to 250 crore Indian rupees. I think this is very, very heavy penalty, right? And that means the government of India is taking utmost care to protect your data from any security breach. So I'll just want to basically come to the data center itself, and I'll just want to give some trends in the data center. So those of you who are aware of PUE, it's like power usage effectiveness. It's kind of power which is drawn by IT equipments in the data center, because most of the applications are hosted on the IT equipments. Okay, so it has to draw more power than some other facility equipments. And if you see, the ratio is reaching to its maximum lower point. That means you have no challenge in terms of achieving the PUE because of so many factors. Now, the very first factor is the servers improvement. So earlier we had servers with kind of SAS or kind of mechanical hard drives, right? But now we have SSDs. There is no mechanics inside. It's just pure play. It's like a USB, and it consumes less power. So I'll just give you one example. If you buy a Samsung SSD, it will consume 1.4 watts of power when it is under operation. And when it is idle, it will kind of consume 0.3 or 0.03 kind of power. So it depends whether it's under operation or under idle condition. Now imagine if the same data server has the old SAS kind of hard disk, it would have consumed 7 watts of power, which is more than double or more than 3 times. So that's one improvements we have done. So these are contributing to reduce PUE. Apart from that, we have there is always you will see there's a fan on top of the CPU. Now this fan is continuously on. I mean, if you recollect the old desktops, you'll always see the moment you turn on the desktop, you will see that noise coming in. That's a noise of the fan. But nowadays, the servers comes with variable fan speed. That means if there is no heating happening or there is no operation happening, that time fan will not rotate, or it will rotate with a minimum speed. Again, that helps you to reduce your power. So there are many things happening. The IT equipments are raising their temperature thresholds from 18 degrees centigrade to 25 degrees centigrade. Again, that helps you to lower your cost on the cooling requirement. So many things are happening in data center world. And I think we are reaching to more or less threshold, and beyond this or below this, I think nothing is possible. So where is we see things happening, or where things are ramping up? So I will talk more about those things in my next slide. But before that, I just want to say something more, because most of us, we hear about data center and we say that yes, data center building is very costly, but then how do we analyze the cost? Okay, so I have some figures from from third party company called Omdia, which clearly states if you basically put this particular data center in 3 different buckets. One is a land and building cost, second is a physical infrastructure cost, and third is IT infrastructure cost. So your IT infrastructure basically contributes 66.5% of your overall capex, right? And remaining contributes to your physical infrastructure, or we call facility. And basically it is used for powering on your servers and cooling purpose. Whereas the IT infrastructure is the core infrastructure of your data center, which basically hosts your business critical applications and serve your clients or your customers. Now, in this 66%, we have server storage, the switches, we have IT infrastructures, which contributes to cabling, firewall, and other things. But then what is the largest scale, or which is the material hardware, which basically contributes more consumption of power? Okay, don't stress. I'll just explain to you. It's a server which basically consumes a lot of power. And obviously, it basically occupies your entire data center space, right? And then if you look at it, all these servers basically do all compute the complex computations, and either they store your data into a storage which is locally accessible, or maybe it basically transfer to the user. For instance, if you want to check your monthly balance on your mobile banking, or probably on your internet banking, it will not throw all the data from last 10 years or 20 years. It will just give you some portion of the data which is already stored on the storage, right? Now, since you're using mobile phone, you feel that everything is happening on wireless, right? That's correct. But inside the data center, you still require a passive infrastructure. Okay, so I'll just probably show you how this servers looks like. On my left, you will see there are two types of server which are predominantly used in most of the data centers of tier 2 or enterprise class, which are maybe rack mount servers, 2U size, and blade servers with a multiple small half slice blades inside. In the middle, you can see a huge rack, which is called a storage. That's where all your data is being stored for your future reference. On your right, you will see there are two types of switches. One is Ethernet switch, and the second is SAN switch. All right. Now, how these devices talk to each other, and how they have basically changed the way they operated few years back to today, to this point of time. So I'll just give you some bird view of a typical data center, where the blue boxes, what you see, are the places where all these IT hardwares are stored. And the yellow pathway, the fiber raceway, what you see, from where all the cable moves. So these cables are responsible for connecting or for communicating, establishing the communication between the devices which I shown in the earlier slides, right? And if you have this particular cable in a proper shape, this particular cable will help you to communicate with a higher bandwidth, with a low latency, and with a better performance. I will just share you some slide where I can show you how they are connected. Most of us are aware of it, but then just in case if you are not, then this is a typical architecture on your left, where you will see there's a web server, there's app server, there's a database server, right? And these servers talk to each other with Ethernet switch, right? And there's always the data stored on the storage devices. And for that, you require a SAN switch, correct? So this is just a line diagram, which I just want to basically show to you on the left side. But if you look at the right, this is how the typical connectivity will be. Again, the servers which I've shown are rack mount servers, blade servers, the storage inside, and the various connectivity part. So with the advance in the bandwidth, or with the demand for more bandwidth, the copper cable is slowly phasing out, and its job is only to manage these devices. Whereas the fiber cable is taking a driving seat now, and they are contributing more for higher bandwidths. So right from 10G, 40G to 100G, to a certain AI ML kind of clusters, it might go from 100G to 400G, right? So the fiber cable which was used for telco is now becoming the de facto standard inside the data center for the various reasons. Okay, so how this cable looks like. So when you see in this in the middle, the cable has different categories. The cable in blue is OM3 multimode fiber cable. The cable in Erica Violet is OM4 fiber cable. The cable in yellow color is the single mode fiber cable. Now, you will see this particular fiber cables have got connectors pre-crimped, or basically they are crimped in the factories, so that it basically saves your time during the installation in the data center, right? The structured cabling probably will help you to plan your current applications, the current connectivity, as well as your future connectivity. Because one single fiber cable, which you see on the screen, has got 12 fibers or multiple 12 fibers, right? And it occupies lesser space. Again, if you see the tray on the left and the kind of ODF panel on the right, it basically has got 1,000 or probably 4,000 kind of ports in per racks, right? So this basically is the, I would say, highest count fiber ODF which we have from our Belden series. Now, how it helps you? Basically, it helps you to deploy any application, any business servers, and basically on the fly, you can establish the connectivity between the MDF or probably EDA and MDA, and then connect to the telco racks, and then you're up and running. Also, if I can just show you few high configuration fiber cables in the next slides.
Mr. Mahamunkar, can I ask you how long is the presentation more? How many more minutes?
Yeah, I think it's another 5 minutes.
Yes, please. Yeah, just so that we can schedule it.
Yeah, thanks for reminding. Okay, so again, if you look at the first picture on the left, which is 12 fiber, and the last picture on the slide, which is 144 fiber, it takes very, very small space on your pathways, right? It has got pulling eye. So basically, after pulling that cable from right rack, from source to destination rack, you can cut it off and make it look like a normal cable. It contributes less space, but high configuration helps you to plan your future upgrades, right? And these are the few panels which we have, right from 1U24 port to 1U48 port and 1U72 ports. That means in terms of fiber, 144 fiber in 1U. And then basically we have that migration options available from 10G to 40G, 40G to 100G, and then with a various base configuration like base 8 and base 12, right? So we have 1U, 4U, and multiple options, which is field termination as well as pre-terminations options. These are the few pictures, and with this, I will probably in my slide. So when you see this picture, you will come to know that whether it is an MPO trunk cable or it is a splicing solution, it can be mounted with a high configurations panels, and basically it saves your passive footprint in the data center so that you can use the space for your active hardware. With that, I will end my session here and open for the Q&A and the technical session. Thanks for your patience.
Thank you.
Appreciate it.
Thank you very much, Mr. Mahamunkar, for an excellent presentation. May I request you to please stop sharing the
Sure.
screen? Wonderful. Okay. We are now on to the discussion part of it, and let me introduce the other panelists who are there, and this will be in alphabetic order. Just make sure that I have, yes, yeah. So we have with us, we'll have with us a little bit later, Mr. Girish Dhawale, who is CTO Data Center Services, CV Technologies. He's got about 25 years of experience in IT industry, telecom, data center, and cloud space. He's responsible for creating and implementing innovative data center technologies, ensuring quality assurance, service management, risk management, and operations. He closely works with customers in formulating their future data center strategies. In his previous assignments, he's worked data communications with AWS and with Reliance Communications. As I said, Mr. Dhawale is going to join us a little bit later. We also have with us Mr. Amit Kumar, Senior Solutions Architect, Amazon Web Services. He has an experience of over 2 decades. He's a multi-cloud certified architect and skilled in cloud solutions. VMware Server, VMware ESX, VMware Infrastructure, VMware View, and Linux System Administration. He has a master's degree in computer science. Welcome, Mr. Kumar. Very nice to have you with us, Mr. Kumar. Also with us is Mr. Anil Nama, who is Chief Information Officer at Chris Data Centers, CtrlS Data Centers, I should say. And he's got about 3 decades of experience. And as CIO, he's responsible for supply chain management, product innovation, and business strategy, with a strong focus on evolving innovative solutions for vertical specific and multi-platform requirements. And this includes AI operations, service augmentation, hybrid cloud capability, information assurance, and user experience. And this year, his focus is on the pan-India rollout of CtrlS NLD, edge data centers, private cloud, MSP, and MSSP services. And as a veteran, he's been part of Computer Network Offense as defense. And very warm welcome to all of you, to Mr. Nama, to Mr. Kumar. And as I said, Mr. Thavale is going to join us later on. I think what we are going to do is we are also going to discuss questions. What are the emerging connectivity requirements for data centers? What are the key challenges being faced? What role does the fiber play in the connectivity? How can structured fiber cabling be leveraged for building future-ready data centers? And what are some of the innovative deployment models? We'll be discussing these over the next, I should say, next about 50-55 minutes. But before I come to that, I'm going to ask Mr. Nama and Mr. Kumar if they have any questions or any comments on what was presented by Mr. Mahamunkar. Mr. Nama, if I can come to you, you're muted, sir.
Yeah, so I mean, what Mahesh has just talked about, fiber is coming into the data center, and that's very, very true. As we see the customers, as we see the new rollouts, we see less and less of copper and more of fiber coming into the way. The circuit size also is increasing tremendously. I mean, gone are the days of 1 gig and 10 gig. People are talking, general today connectivity is 40 gig and 100 gig. And people need between 400 and 800 Gbps of interconnectivity. And that's the way we are going towards in future.
Okay. Mr. Kumar, any comments on what Mr. Mahamunkar presented?
Yes, everything has been covered. So, but just want to bring everyone's attention on one piece is because of the nature of content of the user who consume those content is going towards on a high definitions and 4K, 8K, which requires a lot of bandwidth. And then coming back to as a provider, I think we should be really aware about that how the networking component would help your applications towards that. So earlier it used to be networking used to be just a server where you provide the just a connectivity and you really don't care about what kind of a bandwidth and what kind of an content is going on those pipes. But these days, the things are getting changed. When we are planning an applications, I think we should also plan your network pipes also. And fiber is definitely one of those, planning sessions. So more we're going to cover in the conversation. Thank you.
Yeah. Okay. So let me just get to the little bit further in terms of what are the emerging requirements. I'll come to you again, Mr. Nama first. Mr. Nama, you talked roughly about some in terms of bandwidth, what is requirement. Could you just tell us in terms of maybe a little bit more in terms of how you think these requirements changing? What were they, let's say, 3 years ago? What were they 2 years ago? What were they 1 year ago? What are they now? And how will it change? And also, are there other elements to it in terms of, as opposed to simply saying, this is the total data requirement? Are there other elements in terms of, are there times when it's peaking much more than it's other times? What are the bursts here? What are the issues? Is it as simple as just bandwidth, or is there more complexity involved? If you can help us that, Mr. Nama, please.
Sure. So see, data centers roundabout. If I take the PUE graph of Mr. Mahesh, so till 2010-11, the data centers which were made predominantly had a structured cabling which was mostly copper. Which was around 10 by 100 by 1000, which means 1 gig circuits were supposed to be very big. And you had SAN connectivity between 4 Gbps to 8 Gbps. If you go to the architectures which came till 2018, the 1 gig LAN became 10 gig. and we saw the 10 gig copper turning to SFP, which means fiber. So the ports in the servers, the amount of processing that it had, the amount of RAM it had, the throughput requirement increased from 1 gig to 10 gig. And then because of the long distances and the latency, SFP or the fiber was getting preferred even in the LAN. The SAN side increased from 8 Gbps to 16, 16 to 32 Gbps. Now, as we talk data centers till last year, the kind of cores that have come in, 32 cores, 28 cores kind of servers, small form factor like 1U can handle up to, let's say, 2 terabyte of RAM, and therefore the throughput now increased to 25/40 gig. That was the standard port. 25/40 gig is the standard port. The LAN was predominantly had become the fiber LAN, and the SAN continued to be 32 gig. But because of the advent of, from Amit's platform, the AWS S3, the object storage, suddenly the block storage started to move towards the object storage and the NFS file systems. And therefore, the SAN also started to merge into the LAN part. Now, as we talk today, the landscape out there is changing. The landscape is changing in terms that people are moving to hybrid setups. Even a CSP like AWS is moving to multiple availability zones or multiple pods or multiple buildings in a singular city. Now, when you take that data outside of data center, so while a 1 gig internet may be consumed, a 2 gig was the one of the largest banks in India consumed 2 Gbps around about 2008 and 9. And they consumed roughly 40 gig around about 2018. And now what we are talking about is if we connect two zones or in a hybrid scenario, two data centers, each data packet going left and right between app and data. We're talking about bandwidth requirements of 800 gig and 1.6 terabit. So from a WAN side, it is changing very, very dynamically. Earlier, WAN circuits were 2 MB. I remember in Airtel days in E1, a 2 MB was a circuit we used to sell. But today, if you ask, they want 100 gig, 400 gig circuits just to interconnect the buildings. And then within buildings, everything is fiber. Because at the end user destination, we are also talking on Zoom. So the post-COVID era, the amount of consumption by a corporate user has increased by 8x. Now, the 8x of the bandwidth that he pumps now translates into 8x of bandwidth that is getting inside the DC. And that multiplied by 8 is the amount of communication that will happen within the app, DB, etc. So that will increase by an order of 2 to the power of 6 or 64. Future, what we are seeing is there is a lot of offloading that has started to happen. For example, for us, when we built Patna and Lucknow DCs, we thought maybe it will be taken by some local providers there to put in their IT assets. For example, a local company, they are putting some SAP, ERP and all. What we instead found was people from the provider side putting their edge sites there. This is from a masses. So while the masses consume it on a smartphone, so you have OTT kind of platforms which are putting it there. You have TNS platforms putting it there. You now have got also the cloud, the CSPs are coming and putting the edge sites there. And that translates to even higher WAN bandwidth. Because earlier we were talking about between the buildings. Now we are talking about a 400 gig circuit between cities. That too at a remote location. Because they want a low latency network. And similarly, the density of servers also keep on increasing. With the advent of AI, the GPUs and all, the one new server which was like 300 watts in 2008 has now come to roughly 3.2 kilowatts per U in the 2025 time frame. So that's the changes that are happening.
Mr. Kumar, if I can ask you the same question, from your point of view, and of course you have a different kind of view because you're able to view a lot more in many ways. What are the different changes you are seeing in terms of connectivity requirements? How are they changing? How are they emerging?
So, I want to start this conversation. It's a very interesting topic. And
Sorry, before you answer, let me just mention to the delegates, if you can please share your comments on chat, and if you can share your comments on Q&A. You can message to me as one or two of you have, but I would prefer if you put it in the Q&A tab as much as you can. Of course, I'll still relay the questions that I'm receiving to the panelists as well. Yeah, go ahead, sir.
Yeah, I was just mentioning that this is an interesting topic, and I want to bring everyone's attentions to the past as well, because we always learn the things from past. So I remember, I was not there, but I read it a lot around this. The first networking was done somewhere around 50, 60 years back. There is a lot of invention has been done on the networking. In fact, in the 70s, the org name called ARPA has introduced first network model, which was built in connecting three mainframe computer together. And there was a very initial days of having a networking requirement. And that was the innovation which came through that for the obvious logical reason that they want to separate their mainframes from each other. And that's where they want to connect it. So I want to start this with two important topic is that we have to understand the need of the consumers. So majorly, if we have to divide these network requirements, there are two majorly. One comes with the consumer, two servers, mostly like, the mobile networks, the computer networks, or probably we can say the connected cars, everybody needs nowadays connected home appliances, connecting this, connecting that. So everybody needs those connecting ability to connect their devices to the internet or connecting their devices to the central location. The another important piece comes in when we discuss about computer to computer, which is more important than in terms of bandwidth, in terms of requirement of those connectivity. And that, of course, Mr. Nama was mentioned about connecting two availability zones together to make their applications, the customer applications, more resilient in terms of availability. So that requires a lot of bandwidth and a lot of connections. And coming days, and I think Mr. Nama has also touched upon, the important piece comes when we talk about the fiber cables and fiber channels and fiber requirement in terms of connectivity between two systems, is when you are thinking and building your applications towards the Gen AI, towards the machine learning, towards the AI analytics platform, where the lot of GPU requirements comes in. And these systems doesn't work in a silos, like one computer is just doing the things and then serving. There are n number of computers. Sometimes if it's a large application, there is 1,000 servers running at the back, talking to each other every milliseconds, and then requiring a lot of networking power. So there. So like AWS, we have lot of innovations at the back. And in terms of requirement, we hear from the customers. And just for an example, I just want to highlight one thing about AWS is that we have purposely building the hardware at the back, including the on top of software at the back, so that we can serve the customer. One fine example is that we have 600 plus EC2 type at the for our customer, which is purposely built for specific compute and networking requirement. So one EC2 instance probably good for web server, which doesn't require a lot of networking power at the back. And we have another type of different EC2 we have lot of networking power at the back. So like 10G, 32G, and a lot more than that. And if you have an ML EC2 instance talk, it comes with a lot of good bandwidth at the back. So, in a nutshell, it all depends when we are talking to an applications or we are talking to a particular type of an application, what kind of a requirement it is and how we would be able to serve it. But in a nutshell, the networking is, like I said earlier, networking is an integral part of your application planning that you are doing.
My next question, I'm going to begin with you, Mr. Kumar, and I'm going to ask you, what are the key challenges that are currently being faced? What are the issues? What are the concerns? What is not so straightforward? What gives you a headache? What sort of, I wouldn't say keeps you awake at night, because nothing should.
Yeah.
What worries you?
So I again go back in the past, and then I bring this conversation to the future as well. So initially, when we take the challenges as an opportunity to innovate on behalf of our customers, and customers, we keep receiving signals from the customer, they need more. I'll take an example of our services S3. Mr. Nama has mentioned about it. So we introduced our S3 services in 2006. Since then, we are hearing a lot of feedback from our customers. And a couple of customers say, they won't be able to upload a large file in our object storage for the obvious reason, because at that point of time, the networking and internet was not that capable to take that large file to S3 and then, serve as an S3 object storage. But then we hear from them and then we innovate. This was the first challenge we faced within S3. And then we innovate at the back and then we introduce a couple of more services. For example, like we had one of the feature in S3 is a multi-part upload. That solves a lot of problem, not just one problem that the customer was not able to upload a large file, but we also solve the pieces when it happens sometimes, when you are uploading something, network connectivity, hop and hop off here and there, intermittent issues, and then you have to redo it again because you were in the between of that upload. So we solve that pieces through multi-part. Even if the networking goes down for some reason at the back or at the customer end, we do the multi-part upload in such a way that we divide that file into a multiple chunks, of course visible for their internet, and then upload it in the parts and then again group them part together to make a one file. So I mentioned about this, but there are challenges, but we take those challenges as an innovations at the back. And there are a couple of other challenges which I would let other also talk about it. But one thing is more important is do not feel challenges as a roadblock as an innovators. And as a consumer of those applications, please provide the feedbacks to your providers. And as a providers, you take those challenges, hear from them, and then innovate on behalf of your customer.
Okay. Mr. Nama, same question for you. What are the big challenges that you're seeing right now? What are the things that worry you? What are the things that concern you? What do you see as issues?
The big challenge for a data center provider now is the energy density and the network density that's going to come up as more and more AI or GPU workloads are adopted. I did touch upon servers becoming 3 kW. Now, a single rack, if you put 10 such servers, is 30 kW. If you put them like a blade chassis, it will become 50 kW. How do you bring out that much of heat from there and cool the servers in the running? So what kind of solutions like liquid cooling, etc., that we need to design, or the new design of the new DCs going to come in future? How much resilient it will be? And of course, there are certain taboos. Water was never allowed, or liquid was never allowed inside DCs. Once we introduce that liquid, what are the risks? What are the possible mitigations? And so on and so forth. The second challenge is with this kind of servers, we are talking about, thick pipes landing right from the servers till the distribution point. So how resilient will be those architectures? Will they be latency prone? Will the existing routing or whatever transformation technologies, will they bring in latencies? Will they not bring in latencies? And at the same time, the threat landscape is also going to multiply. Because just imagine a DDoS attack on those type of servers. So what kind of disruption could they bring? So these, the energy, the throughput, and the kind of risk profiles that are going to come tomorrow are the things that keep us awake in the night, mulling over the issues, talking to various OEMs, talking to various innovative companies on how to overcome those challenges.
Okay. Mr. Mahamunkar, when you were listening to Mr. Nama and Mr. Kumar, what are the thoughts that were coming to you, and any comments you have or any response you have to what they said?
Yeah, sure. So I think I keep on getting this kind of, this is a very, I would say usual conversation which we have with our customers and prospects. And then the very first question we ask them, like, what is your, roadmap? Like when you talk to the OEMs, what is your roadmap in terms of scalability? So scalability comes the big challenge, and becomes more and more complicated as you grow in the business, because businesses are growing exponentially. I mean, they are no more a linear there is no more a linear curve in the business. And that is where our consultancy gets into a picture where we try to understand which are the applications. When I say applications, a network application, is it 40G, 100G? Is there any roadmap for 200G? If yes, so then what is the fiber cable they want to go with? Is it a parallel technology they want to go with, or a serial technology? Whether it is an MPO connect or it's a splicing solution. So many things basically come into a picture. And many of times, the colo partners or colo operators, they have a dedicated space kept for the cloud or hyperscale providers and for the retail customers. So they have, as Mr. Nama was talking about, if you ask them any point of time, what will be the capacity of any server rack, or whether it is 3 kW or 30 kW, it's basically, it cannot be predicted, because the businesses which are coming in, they come with their own set of hardwares, or probably they have some specification that basically completely change your perspective in terms of drawing the power and the cooling requirement. So yes, the scalability is the big challenge we face. The latency, the low latency applications is something which is catching up slowly. And of course, both the gentlemen have spoken about AI ML, which requires GPU. It's not CPU, GPU, right? And then GPU itself, when we talk about server to switch connectivity, we normally talk about 25G to 40G. But when it comes to GPU, we start from 100G, right? So that basically changed the whole perspective. So yes, these are the two things which I think are very challenging as for me, and I often keep on hearing from most of the customers.
Right. So let me go to the next question, which was given to me to ask you. Although I think the answer might be pretty self-evident. What role does fiber play in data center connectivity? Let me ask Mr. Kumar that first. Mr. Kumar, what role does fiber play in data center connectivity? Although it seems pretty obvious to me, but nonetheless, I'll ask you to spell it out.
This is a great question, and when one should understand, there are different type of connectivity options in the data centers as well as in the cloud. I won't be able to share a very detail, because that's something which is the security and compliance related. So I won't be able to share that how the fiber plays a role in AWS data centers. But in a general, I see the connectivity is majorly on a three side. I see when the fiber plays a very important role. One is the DC to DC. Of course, if it's a customers, you have two data centers, you want to connect and you make sure that everything goes through fine, and there's a lot of data happens from DC to DC. And then another could be the cloud to cloud. There are people who attach two cloud together, and then they serve applications with the multi-cloud space. And then another important one, which is majorly most of the customer, and I would say 80% of our customers are using DC to cloud kind of connectivity options they opt. And fiber is a more matured now, and invented by multiple telco providers, which they are doing a lot of innovation at the back. And with those innovations, today, the customer would be able to connect their data centers with the cloud in such a way that they are expanding their data centers. And we also at AWS has spanned across multiple network providers. We partnered with them and then innovate on behalf of our customers and introducing a lot of services like DX, like direct connects. Now with that direct connect options, they can opt for a fiber channel or other connections, different type of connections with these service providers. I don't want to name few of them here, but there are network providers who provide the MPLS connections, who provide a connectivity from their data centers to the AWS cloud directly, which enables our customers to privately connect with the cloud, which gives them a lot of ability and a lot of confidence when they are moving their data from cloud to their data center or data center cloud, or probably serving their end users from the cloud. So because they're important data and then critical data, it's sitting in the private channels, and they got a lot more confidence over there. So that's number one. And then second, that we do have other services like VPN connections and client to site or site to site connections that we offer with the customers. And every single options that we have in AWS is a secure one. So I'll take another example is the site to site VPN for the time being. And because site to site VPN is over the internet, because you don't get a very point-to-point connectivity and private channel for you if you are not that large of enterprise customers. You definitely don't want to spend a lot of money just connecting your data centers to the cloud with the private channels, and you don't have the use cases for that as well. So I would not suggest to do that. What are the alternate options is that you can have a VPN connections over the internet. That VPN connections also, everybody knows that it's also a secure channel where you do some kind of an SSL offload from here and there, and then you encrypt your packet in such a way and send over the internet, and then somebody will pick that packet and then unlock it. And it happens this way. But we at AWS take the security very seriously, and it's a day zero job at AWS. What we also offer, even if you are not sure that your private channel like Direct Connect, which you have an MPLS connections from a network provider, you also want to secure that also to make sure that your packet won't get compromised even if between those network providers. So you can have a site-to-site VPN connections on top of your Direct Connect, so that you got a one private channel kind of a confidence, and on top of that, you're also getting VPN on over it, so that you doing a multi-level, or I would say multiple layers. You are securing your connections on top of this. So in a nutshell, for me, fiber is a building block, a key building block, I would say, for these connectivity options I just explained.
Okay. Mr. Nama, if I can have your thoughts on that as well.
Yeah, so let's understand from the consumer part what's happening. So India did jump the telco loop and went into mobile. Today we are seeing 4G, 5G rollouts. What happens? A smartphone earlier, which was like 8 kbps or 16 kbps, is suddenly a 2 mbps to 10 mbps device. Because of the proliferation of OTT platforms, we are also seeing people adopting things like IPTV instead of the VSATs, which were till the start of maybe 2 years back. So IPTVs are in. What you are finding is that a lot of fiber is moving inside the homes. All this fiber needs to convert someplace to take the data. That earlier used to be telco circuits. Now, because it is no longer telco, it's the data which is going in. All these are now coming as a head end to data centers. You may call them as edge sites, you may call them as a convergence site, but this is where it's getting terminated. And that is where you have got the end or the edge devices of these setup coming in. On the second side, in the enterprises, you see adoption of hybrid cloud. Something I have and something I will put there. So something I have, let's say, is my DC. Something I will put there is, let's say, because Kumarji is there, so we'll say, it's say AWS. Now I need to connect between them. Few of the applications are there on the public cloud. Few of the applications are there within my DC. I mean, even if we want to just take a thumb rule, let's say the front office, the website, etc., the sales things are there online, the e-commerce, and the back office, the financial accounting, the supply chain, etc., is back office. Now, these two applications also need to talk. And therefore, the throughput, which was like a WAN output from a DC, now the same DC is extending its LAN to the cloud. So that brings in a second set of throughput that is coming. And let's look at the technologies which are available. One is copper, one is fiber. Copper has got a length restriction. After some time, by the very property of the copper metal, there will be resistance and you will have attenuation and your noise will start to come in. Therefore, for long distance, you are only dependent on the fiber. So now you can measure it by thumb rules. International traffic, 95% moves only on IPLCs, which are fiber-based. So any country to country connect is generally fiber, which is undersea, and that is where maximum traffic goes. Within country, as we talk, there is already a power grid, rail, and you have all the telcos. Along with that, the government of India has also taken an initiative under MORTH. So all the national highways, they are laying out the fibers, and at each toll station, they will have the repeaters. So you have got 320 terabit or 100 terabit plus connectivity at the highways. And then you come inside the DCs. So the telco rooms are changing. Earlier telco rooms, if you had a Tata or a Airtel Mux, people were taking, like I said, even 2 Mbps circuit to 40 Mbps circuit. But now the circuit sizes are directly fiber terminations. They are taking circuits, WAN circuits between 1 to 100 gigs from the telcos. And now, as you move from the telco, inside the DC, from the MUX room, inside the server racks, the servers have become dense. They need to talk to each other. So that also is becoming some 100 gigs. So all in all, outside of the compute and storage, every place else, you are starting to find greater than 80-20 Pareto rule. 80% is fiber now, 20% is copper. And that's why we can conclude to say that fiber is a very important element of what the digital transformation is happening, and its impact on the data center is very, very high.
Mr. Mahamunkar, my next question to you, Mr. Mahamunkar, even though you did mention that in your presentation, but maybe you can summarize it for me. How can structured fiber cabling be leveraged for building just, I guess, more future-ready data centers? And what are some of the deployment models?
Yeah, it's a very good question. So see, what is happening is like I just mentioned in my slide, things are moving in a very faster pace, and then it's happening in a way it's like never imagined or unprecedented. And the businesses are kind of not ready to wait for 15 days or 20 days or 2 months to set up their data center or probably set up any application. They want to do it overnight or overnight probably, or maybe in a couple of days. Now imagine if you don't have a proper structured cabling in place, then laying a cable in a highly filled or probably overfilled pathways and pulling it without disturbing the existing fiber and then putting it at the right place is a very, very challenging job for most of the data center operators. So the structured cabling basically helps them to plan their current business as well as some unprecedented, I would say, growth in the business. And at the same time, they can actually reduce their, some incidences which are basically happen because of, pulling off a certain patch cord unknowingly without a labeling, all those things. So structure cabling basically help them to control the inventory and the backbone so that they can accommodate the new customers. At the same time, they can serve the existing customer with more efficiently. So it's very important to have, a proper structure cabling and plan their business.
Okay. And what about the deployment models?
Right. So again, the things are changing in a bit. As we talk about 40G, 100G, but people are talking about 800G, 1.6. I think people like AWS and the hyperscale cloud service providers, they have already the plan in place where multiple ports of 1.6 or 400Gs are going to be very, very normal going forward. But what I probably observe is that all these high bandwidth ports require more power consumption, right? So people are working on the co-packaged switches, right? So normally when we talk about transceiver, it basically converts your optical signals into electrical signals, and thus it consumes more power. But with a co-packaged, you don't have to basically do all those things. Everything is embedded inside the switch, and you just put a fiber cable, and you're done. So I think I would see going forward there will be a change the way we look at the overall power consumption. At the same time, we are going to see a huge increase in the data and the bandwidth. Okay,
Okay.
so that's why where people are going to basically shift their inventories from the transceiver to co-packaged optics.
Okay. Let's take a few questions from the audience now. We will come back to the discussion perhaps, but I've seen quite a few questions here. The first question is for Mr. Nama. It's from Shashikant Kasabe from Nvent. He says 3.5 kilowatt per server. Then what is the suggestion on data center cooling solution that SIF is looking for? Liquid can be used or still is limited to 10 kW per rack.
Okay, so let me correct. I'm from CtrlS data centers, not SIFI.
Yeah.
What's happening is the air cooling is limited to 10 or 12 kW. Beyond that, you have to have liquid cooling. There are two forms of liquid cooling that enable you to increase the load density in a rack. One is with the standard GPU servers which are coming in, which is like 4 into H800 or 8 into H800 kind of GPU cards. The liquid cooling is a inbuilt liquid cooling, closed loop liquid cooling. You can compare it something like 2015, 2016, what happened in data centers when we had the data centers covered and there was a XDR, XDV units which came in, which enhanced the cooling. So this type of cooling solution doesn't do any change externally. Internally, the fluid, instead of going inside an AHU or air handling unit, it goes inside these type of units, which then have adiabatic converter or a heat converter loop, which takes out the heat from the servers, and this can easily scale up to 50 kW per rack. Beyond 50 kW per rack, if you are consuming load, then presently the answer is immersion. So you do immersion cooling. Immersion cooling has its own challenges because the whole setup that is there, you will basically immerse your servers. Now that requires a different level of connectors. That requires a different way of handling the servers because everything is immersed. So even if you have to change a spare part, you need to bring it out and then wait and then change. Are people using it? Yes, we have started to see the advent of the people using it. The servers with this first technology that I said are used by most of our customers.
Okay.
And the second, the immersion cooling, we have very few customers, but then just think of the scale. Sometime back, a 300 rack data center during 2009, 2010 was like 1 megawatt or 1.44 megawatt was the unit size. Today, that same thing can be given in 10 racks with immersion cooling. So 300 racks converges to 10 racks with the new technologies. So this is how it is going in. What is beneficial to us, or especially in India, was because India didn't have most of the air handling units were being fed by the coolants or chilled plants from outside. So we didn't have the split air conditioner kind of cooling. So we had outside water cool, inside was the air. So I mean, it is just adapting that water flow to these new units. This is for all data centers which have come in post 2016. All data centers or in-house data centers which are pre 2016. They were all air cooled outside also or gas cooled. They will have challenges to adopt this system, but the liquid cooling ones, they just need to, change the handling units to liquid, and that's how we are going to sustain.
Next question from Madhusudan. I will direct it to Mr. Kumar. He says, I have a question. What is the maximum number of fiber cores being deployed for connectivity between two data center buildings or between two buildings in the same city?
It all depends. The pipe that you want to have between your two data centers or two buildings of your data centers, that how much is, what are the use cases? Then on top of that, is it a streaming use cases? Is it just an application sharing file from each other to? It's all depends. So there is no, how would I say this? There is no one thumb rule which you can, if you have to connect two data center, how much pipe you should be. So I think it all depends. So that's what I can do. How AWS do at the back, I can share some public information, but can't go very deep into that. How we connected our two buildings, data center, how do we do it, availability zones and the regions. But I can share you a couple of more public information in there. So if you are aware that AWS works on a resilient infrastructure at the back, we do have an availability zones. And if you are aware about what is availability zone, a single availability zone is a group of one or more discrete data centers, and it all different power supplies, different, cooling systems, different, DGs, and everything is different, and different buildings too. And we club them together and then make availability zones. And if you combine these couple of availability zones together, and that brings up a region. So let's take an example of a Mumbai region. So we have a Mumbai region, 3 availability zones. So what that means is these 3 availability zones, and these availability zones also apart from each other's like hundreds of kilometers. So considering that in Mumbai region, we have a 300 100 kilometer here, 100 kilometer here, 100 kilometer here, and we have this kind of a different buildings and different data centers, and we club them together and make up a region. How do we connect with each other? Again, where they can't go very deep into and share some numbers into it, but we have a very, very large pipe of which we share between these data centers together, and we make them a very highly resilient data coming from here and there. For example, if you put a single file in S3, it probably going to land, depending on the type that you have selected, it probably going to land in all these 3 data centers within a millisecond. And that's kind of a use case we have, and accordingly we have built that pipe at the back. Unfortunately, won't be able to share much information because of the security and compliance requirements. And that's my answer. I would probably hand it over this question to the Mr. Nama, which he can share if he can share more information about it.
Thank you. Mr. Nama, anything you would like to add?
Yeah, so sir, for hyperscale data centers, we generally provision 8 ports inter-building. The 8 ports capacity can range from 400 gigs to 1.6 terabit. So minimum is 3.2 terabit connectivity between these 2 data centers, and the maximum is 8 into 1.6, which is like somewhere greater than 12 terabit. It all depends on the design that we get from the hyperscale for connectivity that they want. Sometimes they will take diverse paths. So generally each circuit we put a single switch. Okay. So they don't want everything to go through the same path. They will say you, for example, in Mumbai, and you're in Navi Mumbai, and let's say there is availability zone in Mumbai. They will say you take one through Vashi, you take one through Thana, you take one directly, and one may be going across through the Pune side and then coming in. So they take diverse path because of disturbances, fiber cut and all. But that's how it is provisioned in those terms.
Thank you. This is a question for Mr. Mahesh. Mr. Mahesh, this is from Manish Kumar. He wants to know, can LAN cable solution be replaced by FO solution in data center?
Yeah, so I think, see, I'm not saying it will get, so when I say LAN, it means you're talking about copper, right? I'm presuming he's talking about copper, Cat6, Cat6A, right? So still, in the enterprise class data center, we have all the management VLAN or management network on the LAN, on the Cat6A, because Cat6A is the minimum standard as per TI 942. So that's basically used only for, I would say, non-production traffic, meaning, you often need to upgrade your servers for the antivirus, for the OS, or for anything. So that basically is being used on the copper. But if you talk about production traffic, okay, when you have your web servers accessing app server accessing database server, that is now being replaced by fiber, and it is going to stay for a longer period of time.
So the answer is yes.
Yeah.
Okay. All right. I'll request you shorter answers because then we have many questions that are coming in right now, and I would like to have them as many answered as possible. Next question is from Paul Henry. He says data center interconnections done with high bandwidth length, 800G, versus multiple low bandwidth link, as in 8 times 100G. Can you compare it on economics and technical view like latency, packet drops, etc.? Mr. Nama, do you want to take a crack at that?
Yeah, sir. See, when you are crossing 100 gig, the pipe remains same. Remember, the cost of fiber will remain same. It is just the card which is changing. So 100 gig, 200 gig, 400 gig, 800 gig, it's a card in this switch. So
Right.
when you are taking multiple 100 gigs, there is a cost overhead which will come.
Okay, so
Because
it's
this
better to take 800G versus 8 times 100.
Yeah, a single 800G versus 8 into 100 gig means you will have to invest in 8 different cards on the right hand side, which is switches.
So
And
it's
these
better,
circuits are
for,
not, I
Yeah.
mean, they are not like a carrier mode that I bring a 1.6 terabit and then I divide it to you.
Right.
Generally, these are end-to-end fiber pairs
Okay.
because the
so,
latency has to be less than 1 ms.
so that means 800G is generally better than 8 times 100G on all accounts.
Yeah, you don't replace 800 gig with multiple 1 into 100 gig.
That's not, yeah. Okay,
Or if you have a requirement of 100 gig, you can
Yeah.
take diverse paths 4 or
Right.
5 so
Right.
that you have high availability. But because today it is not multiplexed into a single circuit, it's a point-to-point circuit that we are giving at
Right.
1 ms latency, and therefore it's presently not economically feasible.
The next question I'm going to send the way of Mr. Kumar. This is from Shirish Kanegaonkar. And the answer is, I'm assuming, straightforward. He says, AI automation, is it beneficial for data center or not? Is there any impact of AI or ML? I'm assuming the answer is yes, right?
Yeah, yes, but again, if you look at from what perspective, so it depends on the lens that you look at it. But
Okay.
yes, AI and ML workloads are going to change the data centers, including the hyperscalers as well, from the need of the computes, from the type of the compute processor, the CPU, the GPU, the network cards. It's amazingly going to be changed. It's not going to be a normal card is going to serve your purpose. It is going to be changed, but it is beneficial for all of us, like including consumers, hyperscalers, data center providers, everyone.
Okay. The next question is, I'll send we have Mr. Mahesh. In India, most of the internet traffic is mostly through mobile operators. This is from Miftahur. For applications that are deployed in third-party data center, how is the latency taken care of? Is there location-aware multi-city peering anywhere? Mr. Mahesh?
Okay, I think this question is more to Mr. Nama.
Okay, Mr. Nama,
because-
Mr. Nama, you can
Yeah,
take it.
yeah.
Yeah, so see, yes, the answer is yes. We have location-aware latency peering. Something that we do is known as the latency map, 1 ms, 2 ms, 10 ms, and 30 ms. And that is how you cover the pan-India. And as you bring down the latency, that much level of interconnects you bring in. So overall, the answer is yes. And everybody in this ISP system works at peering points at various locations to bring the customers under the single latency map.
Okay. The next question, I guess, is how the need for growing data demand is to be met? What is the current percentage of consumption of available data centers in India? I guess what they want to ask is how much of the data consumption in India is being met by servers in India. Does anyone of you have is being met by data centers in India? Does anyone of you have?
Yeah, I will just try to give some perspective. Like if you talk about 15 years back, 70% of traffic was outside India. The only reason being is, all the major data center players, the application vendors, they're hosting the data center either in Hong Kong, Singapore, or maybe somewhere in US.
Mhm.
And 30% was within the country. But now the scenario has changed. Now the 70% traffic is, kind of traversing within the country, and only 30% traffic is going out of the country through our gateways from Mumbai and Chennai, right? So yes, so there's more consumption of, within the country data, and obviously it is all consumed or probably churned on the servers. So yes, answer is yes.
Okay. The next question is, how is the process in place for disaster recovery? Do we have to tie up with other nations for our backup centers? Mr. Kumar, do you want to take a crack at that? Disaster recovery, do we have to tie up with other nations? I guess what they mean is, if all of India is, is
Yeah.
boxed by something, then
Yeah. So I think this is again my favorite words are it depends, and it is not a very straight answers that yes you should have or yes you should no you should not have. It all depends on the type of data a particular company or org is planning to take a backup. So if it's a PII data or if it's a data which is very specific to India and involves a couple of important aspects of government of India somewhere, then the Mr. Mahesh has shown some kind of a guidelines which came from the Indian governments and the ministry as well. The data should not leave the country boundaries, and that's where the AWS has launched to two different regions in this. So it is unless the Godzilla comes in, unless the meteor comes in, and then whole India's data centers are down. That if that doesn't happen, almost every hyperscaler and the large data center providers are also have this some plans around it. Let's say I'll talk about the AWS. So AWS has a the separate region, the Mumbai and Hyderabad, which will be able to cater your application if you have designed your disaster recovery on these two regions. Like I said, the region is not just one data center; it is a group of data centers. Even something goes wrong with the whole Mumbai, I'm just assuming, and then you have the Hyderabad region, which has again the similar kind of a group of data centers to cater your application. So to answer in a short, this is a very interesting topic. I can go on and on, but to answer very short in this is that yes, you should think about your data type and accordingly have a plan for your BCP, business continuity plan, that about your customer or about your data that you are trying to take a backup.
Okay. The next question is from Rajiv Jha. He wants to know what kind of regulatory challenges do data center companies have while setting up new data center in India. He's talking about land, building, power connectivity, fiber optics, approval permissions. Mr. Nama, I guess you can answer that question.
Yeah, so there are a total of 87 permissions that are required to set up a greenfield data centers.
Okay.
They go right from shop and establishment where you can put the charging to getting the land use conversion and everything. However, what has happened is because of especially last 2 years, the governments have been taking a very strong view on improving the data centers in India. Each of the states have come out with their data center policy, and roughly 16 states have got a single window DC clearance. And I'm talking about West Bengal, I'm talking about Chhattisgarh, I'm talking about Rajasthan. I'm not only talking about the well-developed states. Right. So you go there, they keep, so they have got some DC parks, they have got pre-sanctioned things, and they allocate you through the single window. So ease of doing data center business, if you asked in the last 2 years, has improved by at least 40x. Because earlier it used to take 2 years to get all those sanctions because you had to have power sanction, environment section and all. But now you get it all pre-approved. And more states are coming up with the DC policy.
Okay. There is one question, which I don't know, maybe my colleague can answer. What is the expected market size of DC data centers in terms of megawatt in 2024? And what's the percentage growth every year? Mr. Mahamunkar, you might be able to give us that information. This is from Anuj Gupta.
Okay. So, I think 400 megawatt is what is the capacity of the whole country's power consumption is, right? And, I think by 2030, we are going to double it by way of going with,
Sorry, are you talking about data center market or total?
No, I'm talking about overall market.
No. He's talking about data centers.
Okay. But I'm not sure about data center market. So maybe some of gentlemen can.
Yeah, I think I should mention by the overall market, I can just tell you the overall installed capacity about 400 odd gigawatt, not megawatt. And the peak demand met has been about 230, 240, 250, somewhere there. But nonetheless, I mean, since we also publish Powerline magazine, I have those numbers too. Okay. Expected market size, anyone has any about data centers?
Yeah, I have it. See, the current market size is roughly 500 odd megawatt for external colo, and it is expected to grow 3x by end of 2026. So it will be at 1.5 gigawatt.
Okay.
So it's exciting time from a DC side.
Yeah, I'm
300% market growth in 3 years.
Yeah, I'm going to just quickly take a minute to do something that I probably should not be doing, but let me do this anyways. We do have a data center market report that's there. I wasn't planning to share that, but now this question has come up. It was released, in fact, just a week ago or so, or maybe a few days ago. It does give you key trends, developments, market segments, policy scenarios, state initiatives, investment landscape, demand projections, energy management, green data centers, design and construction of data centers, some key players. So it gives you all of that. So those of you who are interested, please send us an email and we'll be happy to share that report with you for a price of 80,000 rupees, however. Okay. And all right. So now there's somebody called Dr. Pankaj Dashore who has raised his hand. Iqbal, can you allow him audio right or video right if he wants?
Yeah,
Iqbal? This is he's raised his hand, Dr. Pankaj Dashore. I'm assuming he wants to just ask a voice question. Dr. Dashore, are you still interested in? You raised your hand earlier. Iqbal, could you tell? Yeah, there he is. Yeah. Yeah, Dr. Dashore, can you unmute yourself? And then ask us what, or say whatever you would like to say. Yeah, Dr. Dashore. Dr. Pankaj Dashore, he raised his hand earlier. I'm assuming he's now switched off or. Okay. Yes, sir. If you're still with us, which I'm assuming you are at least logged in, perhaps you could just tell us what you'd wanted to do. Okay, let's move on. And if he hears us, maybe he will come back to us. So my questions to each one of you, my last question is going to be, is there anything that you think I should have asked you that I didn't ask, something that you want to say or something that you just want to reinforce or some closing thought from you? Mr. Nama, we'll start with you, sir.
I thank you for having this particular webinar, especially on the relevant topic of fiber and what is going to happen in data center. It's a really exciting times that we are linking in. One of the points to also cover was the green, how fiber and the current DC can make it green.
Right.
So our answer to that is the fiber consumes a lot less current because copper by its nature is resistant.
Right.
And therefore we are looking at green IT when we consume fiber. Overall, from a data center perspective, we have all data centers providers being asked to source renewable power.
Right.
We've all been building either solar plants or we are sourcing solar power, renewable power for us to the tune of 30%, which is shortly going to increase to 50%.
Okay.
It helps everybody because renewable power in India is one of the cheapest.
Right.
I mean, DG power costs you some roughly 12, 13 rupees. Thermal power is between 6 to 7 rupees. Solar power is like 3 rupees.
Right.
And you have got the hydel power at 2 rupees.
Right.
The more consume renewable, the lesser cost it will be for the IT and therefore more proliferation of the digital will be there.
And I should mention that the design of the data center will always impact energy usage as well. And of course, the choice of equipment as well. Yes.
Yeah.
Thank
So
you.
Leeds Platinum anyways is in. So in fact, if you see all the latest data centers designs, including us, they're all Leeds Platinum certified so that you have even the DC building there.
Right.
We also have this initiative now rolling over. For example, we were forced to do and we were forced and we gladly did it. We are taking STP power in, STP treated water in Mumbai.
Oh, okay. Wow.
So we let go of 1 million liters and we are taking 2 million liters of STP treated and we are filtering it and we are using it for cooling.
Oh, very good.
Those are the type of initiatives towards green that are also getting added as and as the DCs become more and more dense.
Okay. Mr. Kumar, closing thoughts from you?
I think absolutely honored to be here and thank you for having me. I think we have covered almost everything and I've pasted a link in the chat and I think in some of the answers of one of the attendees that AWS Cloud is committed for having a green data centers and we are in towards and that there's a full detailed reports over there. It's just one thing is that start innovating together as a customer, as a user, as a consumer, And feel free to reach out to us, any one of us panelists here. And then if you have anything very specific, innovating idea, feel free to share with us, and we would love to that. With that note, I think I thanks also my colleagues also, who has I learned a lot from them today, specifically on the data centers, which is one of my favorite area. So yeah, please, thank you for having me, and have enjoy. I think everybody has enjoyed it. Thank you.
There is one question that has come in, but I think it's coming late, and we want to make sure we end on time. We always do. So I'm going to skip that. Mr. Mahamunkar, you have the last word, sir.
Yeah, first of all, it was a pleasure to be, part of this panel. Seasoned players and highly knowledgeable, I would say, panelists. So just one thought I just wanted to basically leave it here is that, we talk about data center, we talk about CapEx, we focus more on server storage and the other part, but all these need to be connected, right? They cannot be on the wireless. Still there is technology, that technology is not evolved. So I would basically suggest people to invest their time in working and designing the connectivity part, especially the passive structure cabling part first. Make your infrastructure ready. The way you make your power and cooling ready for current capacity and for the future capacity. Please consider structure cabling as a part of your capacity planning. And do call us, do reach out to Belden team. We have complete team here. We do consultancy. We help to design that solutions and then probably supply the products. So it's a pleasure to be here, and thanks everyone to join it.
Yeah, thank you. It's been a great discussion, and for that we owe gratitude to Mr. Nama, Mr. Kumar, and to Mr. Mahamunkar. And thank you, Belden, for giving us the opportunity to co-host this webinar with you. Thank you again. Thank you for joining us, and we hope to see you at our next Early Ordinate event. Thank you. Thanks.
Thank you. Have a great day.
Thank you. Iqbal, we can close the session.
Thanks, everyone.
Thanks, Kuhu.